Hello, my dear students. Welcome back to my channel. Today we will be starting chapter number 3 from your Curiosity book. So NCERT has this new book now called Curiosity. So we will be doing the chapter 3, that is electricity, from that book. Okay, so let us start. Now, when we talk about electricity, when we are going into the details of electricity, all of you must be aware of what electricity is or the uses of electricity. How? If you look around yourself, if you're sitting in a room and just look at the ceiling of your room, there is a fan, right? So that fan works on electricity. There has to be a light, a source of light in your room, right? So that light works on electricity. So there are multiple objects if you see around: an iron, microwave oven, mixer grinder. So daily life objects that works on electricity, right? So here we have Nihal and his classmates. Okay, they are going for a school trip to Bhakra Nangal Dam. But before their school trip, you know what assignment they got? An assignment from their teacher. Okay, so there was a group assignment in which they had to prepare a presentation, okay, on the uses of electricity. So they have to prepare a presentation in which they have to list down the uses of electricity. So what do? They began looking around. Where? In their houses. Okay, then they looked around in their school, in their neighborhood, in their city. Okay, and finally they also searched on the internet, and to their surprise they found the list growing and growing. Every time they would look at some place, they would find something new adding to their list. So now they thought to organize it under different headings. Okay, so let us see how did they organize it. So you see here, for cooking, they found electricity is used in electric kettle, mixer grinder, toaster, oven, microwave, right? When we talk about lighting, we have lighting at homes, at offices, we have street lights, we have lights in the markets and the factories. When we talk about transportation, we have trains running on electricity, buses, cars, scooter, lift, escalator, all running on electricity. Now, when we talk about heating and cooling, we have fan, room heater, immersion rod to heat the water, right? Geyser again to heat water, refrigerator, air conditioner, etc. Right? Then we have for the entertainment purpose, we have television, radio. For communication, we have mobile phone, internet, and many other purposes like water pump, crane, computer, laptop. Okay, all these things they found to be running on electricity, right? They need electricity either to get charged or to do a particular work. So they created a group of the uses of electricity. So students, what do we learn from this? We learn that we use electricity all the time, right? So let us learn more about electricity. If electricity is present everywhere, you need to learn more about it. Okay, in previous years, in previous classes, we have learned that electricity can be generated in multiple ways. You can generate electricity in multiple ways, like by using windmills. By in windmills, we what do we use? We use the wind energy to generate electricity. Same way, by solar panels, what do the solar panels do? They capture the sun's energy, which is called the solar energy. Then by falling water, this is called hydroelectric energy. Do you know, students, in the beginning of the chapter, we learned that Nihal and his classmates, they were going for a school trip to Bhakra Nangal Dam. Okay, in Bhakra Nangal Dam, they saw and they visited the hydroelectric powerhouse where electricity was generated from the force of falling water. Okay, so whenever electricity is generated by the force of falling water, we call it hydroelectricity. Okay, so in big dams, water is stored in huge amount, and there is an entire setup to generate electricity from that stored water. Okay, and that generated electricity is called hydroelectricity. So what are the ways of generating electricity? Firstly, we learnt about windmills that uses wind energy to generate electricity. We have solar panels that uses solar energy to generate electricity. Then we have falling water that uses the force of water to generate electricity, that is hydroelectricity. And then by using natural gas or coal, we can also generate electricity. So all this, where did we learn? We learned in Nature's Treasure in class 6. Okay, now we are in class 7. So we will be learning something beyond that. So let us see. The electric supply from these sources, where does it go? It reaches our homes, it reaches the factory via wires. All right. For example, at home, what do? We plug in various devices to electric sockets in the wall. Hai na? We have sockets like this at our home. And what do? We plug in the electrical devices into this electrical socket, and we get electricity from these sockets. Now, how do electricity reach these sockets? Through the wires. However, to learn about electricity, we will focus on portable source of electricity. So in this class, we will not be learning about the sources of electricity that comes from the wire. We will be learning about the sources of electricity that is portable, that you can carry. Okay, that most of us may have used. Okay, so let us start. The most common device which is portable and having electricity is a torch light. So we all have torch at our home, right? We keep it for emergency purposes in case if electricity when goes off, or if there is anywhere, if it is dark, then we need a torch, right? So let us learn about torch light. Before learning about torchlight, this is a symbol given to you. What is this symbol? It's a caution. Okay, the danger signs on electric poles and other appliances warn people that electricity can be dangerous if it is not carefully handled. Okay, so never ever perform experiments with power supply at your home or school, because that can be dangerous. Even electricity from portable generators can be dangerous. So what you need to do is you should only use batteries or cells like those in torchlight, wall clocks, toys, radios, and a remote for experiments with electricity. Why? Because they generate a small amount of current which is sufficient for your activity, and it will not cause any kind of harm. Okay, so since we were talking about torch, let us read this activity which talks about torchlight. Now, in this activity, the torchlight, which is also called a flashlight, we will learn how to switch it on. Okay, so if you take a torch and observe it carefully, you will notice there is a lamp at the front and there is a switch on the body. Okay, now when initially the switch is at the backward position, what happens? You will see that the switch, the lamp is not glowing. But when you push it to the forward position or to the on position, you will observe that the light is coming from the torch. You see a flash of light coming from the torch. So why is it happening? Why in the off position you don't get any light, in the on position you get light? There has to be a source inside the torch. So if you open the torch, what will you find? You will find two or more electric cells. So what are electric cells? Electric cells are nothing but sources of electricity. All right. So let us understand a simple electric circuit by starting with the source of electricity, that is electric cell. So you all must have seen electric cell, I'm sure. If not, what are you going to do? Ask your parents to give you a battery or an electric cell which looks like this. Okay, so this figure 3.2 is a diagram of an electric cell. Now, if you notice an electric cell, you will see there is a pointed metal cap. That pointed metal cap is the positive terminal and it is labeled as plus. And then we have a flat metal cap. The flat metal cap or metal disc, okay, is the negative terminal and it is marked as negative. So a cell an electric cell has a positive terminal and a negative terminal. So they have two terminals. The metal cap is the positive terminal, whereas the metal disc, that is the flat cap, it is the negative terminal. So this electric cell is a portable source of electrical energy. I hope it is clear. Do you know what is portable? That you can carry from one place to the other place. So you can easily carry an electric cell from one place to the other place, right? That is why we call it a portable source of electrical energy. All right. So all of you have understood what is an electric cell. An electric cell is a portable source of electrical energy. Now you all have understood how it is made. It has a metal cap and a metal disc. The metal cap is the positive terminal and the metal disc is the negative terminal. And you will see this positive and negative marked on the electric cell itself. Okay. So you can easily identify the positive and negative terminals of the cell. Now, let us come to what is a battery and what is the difference between an electric cell and a battery. So students, if you connect multiple cells together, we call it a battery. So in a torch, you must have seen that we generally use more than one cell. Okay, and they are placed in a particular order. If you can see this figure 3.3, we have a battery made up of two cells in A, and in B we have a battery made up of four cells, right? So in this activity, what are we going to do? Take a torch which uses two cells. You open its cells compartment and take out the cells. Now what you need to do is put the cells back in different order. Also try reversing the direction of one cell. Then slide the switch and check whether the lamp glows in each case. So what are you going to do is you are going to do a little experiment with your torch. Take out, open it, and then you try inserting the batteries in different orders. Okay, reversing the order of another battery, then reversing the order of the first battery. And every time you do this, you switch on the torch and see if the light is glowing or not. Okay, and check for which order the light glows. So you will see that the lamp glows when the cells are placed in a certain order like this in 3.3a. We have the positive terminal, then the negative terminal. To the negative terminal, we again connect the positive terminal and the negative terminal. All right, so this combination of two cells is called battery. So whenever you combine two cells in the correct order, it forms a battery, not just two cells, two or more cells. Like figure 3.3b, we have four cells. So you see again plus, minus, then again to the negative we connect plus, then minus, again to the negative we connect a plus, then minus, again to the negative we connect a plus. So in this way we connect cells together and they form a battery. In certain remote controls or in certain devices, you will see a compartment for the electric cells like this. Okay, and they will have a separation like this, and you will see there is a metal disc at this point and then a spring at this point. Same way, a disc at this point and a spring at this point. So now in this one, how are you going to connect your electric cell? So you have an electric cell with the positive terminal and the negative terminal. So you will take the one with the metal cap, that is the positive terminal at this point, and the one with the negative terminal, that is the metal disc at this point. Same way, here we will connect the negative and here we will connect the positive. So in this way we put the cells, and in these two cells, combination of cells forms a battery, and then an electric device starts functioning. Okay. So for many devices, we need more than one cell. So we connect two or more cells together and they form a battery, just like we saw in figure 3.3. Okay, connecting more than one cell provides energy to the circuit for a longer time and or more energy. Okay, now do you know some fascinating facts about the battery? The term battery is also used for a single cell. We just learned that two or more cells forms a battery. Then how can we use the term battery for the single cell? Where do we use the term battery for a single cell? So we use the term battery even for a single cell that powers our mobile phones. All right. So in mobile phones, our single cell is also termed as battery. Now, coming to the electric lamp. Now, electric lamp, also known as incandescent lamp. Let us learn about an electric lamp, or we can also call it an electric bulb that we see at our houses, right? So in figure, you can see 3.4a, we have a small incandescent lamp which is used in a torch. Okay, so this lamp is also used in a torch. In B, you have a simplified drawing that shows the connection of wires to the lamp or the terminals. Okay, so let us see them. What do we see? You see inside, can you see the small wire? It's a filament. This filament is made up of tungsten. Tungsten is a metal which is used in the filament of the lamp. Okay, so this wiring which you can see over here, small silver color, that is the filament of the bulb that glows. Okay, now this outer covering is called the glass bulb. Now, this filament is supported on two thick wires. So you can see this is one thick wire and this is the another thick wire. Now, the two thick wires is on insulator support. So this is an insulator which is supporting the two thick wires. Then you see we have a metal case at the bottom, that is the terminal, one terminal. And then we have a metal tip, that is another terminal. So we have two terminals, one that is connected to the metal case and the other that is connected to the metal tip. All right. And again, the between the metal case and the tip, you see there's a small insulator. All right. So this is a label diagram of an electric lamp which is used in a torch. All right. So for this activity, you will require a torchlight with an incandescent lamp or light bulb. Many old torchlights, they still use such lamps. Okay, nowadays we have LEDs. Okay, so not everywhere you will get a lamp with such kind of incandescent lamp. So with your teacher's help, confirm that your torchlight uses an incandescent lamp. Take torchlight and examine its lamp. What do you see? Do you notice a thin wire fixed in the middle of the glass lamp? They're talking about this thin wire. Okay, so do you notice that? You will definitely see it. Now switch on the torch. Which part of the lamp glows? As I told you, this thin wire, which is the filament of the bulb, you will see this is glowing. Okay, so what glows in the lamp? The thin filament of the lamp. So the thin wire inside the glass bulb of the lamp glows. The glowing thin wire is called the filament of the lamp. Now, take out lamp with the help of your teacher and inspect it from all sides. How is the filament fixed? Then you will observe that it is fixed on two thick wires which is supported on an insulator. All right. So, the filament is attached to two thicker wires that support it. One thick wire connects to the metal case at the lamp's base, while the other connects to the metal tip at the center of the base. Okay, these form two terminals of the lamp. Okay, and are fixed in a way that they do not touch each other. In such incandescent lamp, the filament gets hot and glows to produce light. So how does it glows to produce light? When you give it electricity, what happens? This electricity is converted into heat energy and it heats up the filament, the thin wire. When the thin wire is heated to a huge extent, what happens? It glows. So that heat energy is converted into light energy. All right. So in a torch, what happens? The electrical energy is converting into the light energy. Now, if your torch has a different kind of lamp, then it cannot be taken out of the torch as it is fixed in it, because nowadays we use LEDs. All right. Yes, so here we have the LED lamp. So LED lamp you cannot take out because it is fixed. The full form of LED is light emitting diode. LED. L for light, E for emitting, and D for diode. So instead of incandescent lamp, in this figure we have an LED lamp for the torch. So we can also observe these LED lamps in activity 3.5. So if you see this activity, the LEDs, we have different color of LEDs over here. So all LEDs have two legs, okay? One of them is longer than the other. So the first one, the one that is longer is positive and the one that is shorter is negative. All right. So the length of the two legs or the two wires connected to an LED is different. Okay. So unlike incandescent lamp, LED do not have filaments. They also have two terminals. One is positive and it is attached to the longer wire, while the other is negative, as I told you, and it is attached to the shorter wire. Can you see the length are different? So one is long, one is short. So the one that is long is positive, one that is short is negative. Okay. So after having learnt about the electric cell, battery, electric lamp, now we are ready to make a torch lamp using electric cell or a battery. So making an electric lamp glow using an electric cell or a battery. How do we do it? Let us construct it. First, what do you need? You need an electric cell, obviously. Then you will be needing an incandescent lamp that is used in a torch. You need a cell holder to place this electric cell. You need a lamp holder to place this incandescent lamp. And then you need four legs of electric wire to connect them. Okay. So first you will remove about 1 centimeter of plastic covering from both end of each wire. So you're taking four electric wires like this, suppose. So every wire comes with a insulation, that is plastic covering. So what you're going to do is you're going to remove 1 centimeter each from both ends so that you get naked wire. Attach two wires to the two ends of the cell holder. So let us see the cell holder given in figure 3.7a. Here you can see this is a cell holder. I told you now, one part of the cell holder has a spring, the other part small metal disc. Okay, so what do? We connect the wires to the terminals of the cell. Now insert the cell in holder such that its negative terminal is towards the spring side of the holder. As I told you, the negative terminal will go to the spring side and the positive terminal will go to the disc side. Okay, that is the other side. Okay, so fix two wires to the cell using electric tape. Now you fix the two wires using an electric tape. Attach two wires to the screw of the lamp holder as shown in figure 3.80, like this. Again, now you take the two wires and then now you take what? The lamp holder, and you attach to the lamp holder the two wires through the screws you can see. Okay. Now, what do we do next? Then we place the small incandescent lamp on the holder. All right. So an incandescent lamp inside the lamp holder, and then wires connected to the incandescent torch lamp with an electric tape, and then we connect the wires to the incandescent lamp. Now we are ready to connect the cell to the lamp to make it glow. The lamp is ready. The cell was also ready in figure 3.7. Now what do? We connect them. Okay, so predict an arrangement. If the lamp will glow or not, write your prediction in table 3.1. If it does not glow, then change your connection of the wires and then again try to switch it on and see if it glows or doesn't glow. Okay, so we in the table 3.1 we have few connections, as you can see, 1 2 3 4. In position 1 you can see we have the cell positive terminal connected here and the negative terminal connected here. In the second one, the positive terminal is connected, the negative terminal is broken. In the third one, the positive terminal is broken, the negative terminal is connected. Again here you can see that the negative terminal of the battery is loose and the negative terminal of the cell is connected to the positive terminal of the battery. All right. Same way here we connect both the ends to the negative terminal. Here we interchange the terminals. So in each case, let us identify whether the bulb will glow or not. So in the first case, what can we write? The lamp will glow. Lamp will glow. Right? So your observation is the current will flow as the connections are properly connected and the circuit is complete. So here we have a closed circuit, or you can say a complete circuit. Complete circuit. Okay, that is why what will happen? The lamp will glow. That is, the current will flow. For the flow of current, we need a complete circuit. Now, in the second case, the lamp will not glow. Okay, and why the lamp will not go? Because you can see the circuit is not complete. It's an incomplete circuit or an open circuit. You can call it an open circuit or an incomplete circuit. So in this case, current will not flow. Okay. Same way, in the third one, the circuit is not complete. So here also the lamp will not glow. Why? Because no current will flow. Why no current will flow? Because it's a open circuit or it is an incomplete circuit. Now, coming to the fourth one. In the fourth case also, the lamp will not glow. Okay, why the lamp will not go? Because you see the two wires of the bulb, they both are connected to the positive terminal. In order to for the current to flow, one should be connected to the positive terminal, the other should be connected to the negative terminal. So here, why the current it will not flow? Because both wires of the bulb is connected to the positive terminal of the cell. Okay, now if you see this one, in this also it will not glow. Now I want the reason from you. What did I just say? That one should be connected to the positive terminal, the other wire or the other end should be connected to the negative terminal of the cell. Okay, but here again you see both the wires of the bulb is connected to the negative terminal of the cell. So in this case it won't glow. Why? Again the same reason, both the bulb is connected to the here to the negative terminal of the battery. Let me write the entire thing for you. Okay, so both wires are connected to the negative terminal of the cell. All right, both wires of what? Of the bulb. All right, now in number 6, the lamp will glow. Lamp will glow. As you can see, in this case, the circuit is complete. The current will flow as all connections are properly connected. That is, one terminal of the cell is connected to the positive, the other terminal or the other end of the cell is connected to the negative terminal. So the entire circuit is complete and current will flow in this. Current will flow. All right. Why? Because all the wires are connected properly. Okay, do I need to write that? No. So lamp glows in the arrangement serial number 1 and 6 and does not glow in the remaining arrangements. So when you look at the arrangements carefully, you can compare for which arrangement the lamp does not glow, what is the difference, what is the reason. We have understood it all. Okay, now an electric circuit. So we have done an electric cell. We have done how can we combine the cells to form a battery. We have done how to connect the cell to the electric bulb so that it glows. So let us learn about the electric circuit we just created in the previous activity. So, students, we learned that the lamp glows when one terminal of the lamp, that is one terminal of the lamp, is connected to one terminal of the electric cell, that is either the positive terminal or the negative terminal. In the similar way, the next terminal of the lamp should be connected to the other terminal of the battery. So, if the first terminal is connected to the negative terminal of the battery, the next terminal of the lamp should be connected to the positive terminal of the battery, and this forms a simple electric circuit. Okay, so this is a setup of a simple electric circuit. Here it provides a complete path of electric current to flow through the lamp. So current will start flowing from positive terminal of the battery to the negative terminal of the battery, and this flow of current will make the lamp glow. All right, so the direction of current is taken from positive to negative. As you can see, I have marked over here. When the terminals of the lamps are connected with those of the electric cell by wires, what happens? The current passes through the filament of the incandescent lamp, and what does it do? It makes it glow. Okay, So with an incandescent lamp, it does not matter which of its terminals connects to the positive or negative, and the lamp will glow as long as the circuit is complete. Okay, as long as the current flows through the filament, the lamp will glow. You can connect this one to the positive and this one to the negative. Not a problem. All right, we just saw number 6. The lamp was glowing. Okay, but when we have LED, how can we make an electric setup using the LED light? Let us see that. But before we see that, we have a fascinating fact over here. You know, students, sometimes you will switch on your torch and you will see, even if the cells are connected properly, the incandescent lamp does not glow. Okay, this is the situation. We say that the lamp has fused. Why? When do we say that the lamp is fused? When we have a broken filament. Okay, so a broken filament, what does it do? It stops the flow of current, preventing the lamp from glowing. Okay, now LED. We have already seen how does LED lights look like. Suppose we have like this LED light and we have a bigger leg and a smaller leg. The bigger leg is positive terminal, the smaller leg is negative terminal. So what do we need? What do we need for this experiment? We need two electric cells. We need an LED of any color. A cell holder will be required that can fit two cells, and then two lengths of electric wire will be needed. In a similar way, we will remove 1 centimeter plastic covering from both ends of the wire to expose the metal of the wire and to connect it with the electrical devices. So in figure 3.10a, you see here. So we have to make the LED glow. How do we do that? Here you see we have the wires. We have removed the plastic covering of both the wires and we have connected to the holder, the cell holder. So insert two cells in the holder. You see one and one. Two cells are already inserted in the holder. We already know how we can insert the cell. So the negative terminal should be towards the spring side of the holder. Now the two cells are connected. So now we call it a battery and the battery is ready to use. Now what do we do now? We connect the LED lights. So what you are going to do, to the positive terminal of the cell, you will connect the longer leg of the LED light which was marked as positive, and to the negative terminal of the cell you will connect the shorter leg of the LED light which is the negative one. So in this way, when you connect, what you will observe, in the similar way, please do a reverse connection, that is connect the negative to the positive and the positive leg to the negative terminal of the battery. So you have two setups, C and D. Now you have to see in which setup the bulb will glow. So your observation should be that in the first case the bulb will glow, whereas in the second case the bulb will not glow. Do you know why? Because in order for the bulb to glow, the positive leg of the LED should be connected to the positive terminal of the battery and the negative leg, that is the shorter leg of the LED, should be connected to the negative terminal of the battery. This makes the circuit complete and the current flows in it, making the bulb glow, whereas in this the bulb will not glow. So remember students, when current passes through the LED, it glows. Always take care to connect an LED correctly in the circuit to make it glow. All right. So here we have some dive deeper things. Let us read through it. Okay. Sometimes you may come across a device in which cells are placed side by side. Oh, we have already discussed it, right? We have already discussed this in the beginning of the chapter. I told you that in some devices we have compartments in which cells are placed side by side. Okay. We have a disc and a spring, and then a spring and a disc in this way. So if you carefully look inside the battery compartment, you will usually see a thick wire or a metal strip connecting the positive terminal of the one cell to the negative terminal of the next. To help with proper placement, what do you see? You see there is positive and negative symbols printed inside, and you have to place it accordingly side by side. All right. Now, let us come to electric switch. In an electric switch, what is the function of an electric switch? How does a switch turn on and off the torchlight? Basically, first the function of the switch is to turn a device on or off. Now, how does it happen? That we will learn through this activity 3.8. So what you need to do is you need to construct a setup in which we have to collect two drawing pins. So you can see we have pins over here, drawing pins, and then we have a safety pin. So here is the safety pin. All right. You can also use a paper clip. You need two wires. You see we have two wires, wire 1 and wire 2. Okay, and a small piece of cardboard. This is the small piece of cardboard. Okay. Now what you need to do is you have to insert the drawing pin through the ring of the safety pin. Here you see the safety pin looks like this. Here we have a small ring and then like this. Okay, so through the ring you put one pin into the cardboard and insert it and fix it to the cardboard piece, ensuring that the safety pin can rotate freely. Then fix the second drawing pin into the cardboard so the free end of the safety pin can go and touch it. So in a way, at a distance that this pin can go and touch this, you have to place the other one. Then connect a wire to each drawing pin. So each drawing pin we are connecting the wire. Our switch is ready. So to test it, connect the wires with a cell and a lamp. Okay, so we will connect the electric cell and lamp and switch as shown in figure 3.8a. So we already know how to connect an incandescent lamp with the cell. So you see one part of the electric cell is connected to the positive terminal of the battery and the other part of the lamp is connected via this switch to the negative terminal of the battery. Right now the circuit is open. This is called an open circuit. Okay. Now, what do? We make this pin touch the other drawing pin. When we do it, we call this on position. That is, if you can see this next figure, this is the on position. Here, this was the off position when the safety pin was not touching the drawing pin. Here, when the safety pin touches the draw pin, the circuit is called a closed circuit or a complete circuit, and the switch is in the on position. So when you switch it on, you will observe that the bulb, switch it on, what will happen? The bulb glows. So this circuit is called a closed circuit. Okay, and this circuit where switch is in the off position, it is called an open circuit. Okay, open circuit is also known as an incomplete circuit, and closed circuit can also be said as a complete circuit. Okay, so a switch can be placed anywhere in a circuit. A switch is a simple device. What does it do? It either completes the circuit or breaks the circuit. When the switch completes the circuit, then the bulb glows. When the switch breaks the circuit, the bulb does not glow. So the switch is used for lights and other devices at home the same way, though they are designed differently. So we have different kind of switches, but they all work in the same way. That is for switching it on and switching it off. That is either to it completes the circuit or it breaks the circuit. All right. So now we will learn how to make a circuit diagram. But before that, we should learn the different symbols that represents different electrical components. Okay. So the first one, if you see the table 3.2, we have electrical components and their symbols. The first electrical component is an electric cell, and the symbol which we use to represent them is, we make a long line and a small line. Okay, the long line represents the positive terminal, the small line represents the negative terminal of the cell, like this. Now battery, what do we do? When we connect two or more electric cells, we get a battery. So here we have two electric cells. For each cell, we will draw a similar symbol. So one cell and another cell. So positive, negative, again positive and negative. All right. In the third, we have an electric lamp. To represent an electric lamp, this is the symbolic representation. For a light emitting diode, this is the representation we use. Okay, so make sure you learn and practice each of these electrical symbols. This is going to come in your exams for sure. So please do not skip them. Now, this is the switch in the on position. You see, two both pins, and the switch is in the off position, here on position, sorry, and here when there is the circuit is breaking, you see there is something that is open. When the circuit is open, the switch is in the off position. All right, so this is the symbolic representation. And wire, you just represent with the help of a single line. So these are the symbolic representations, and using the symbolic representations, what we can do, we can draw a simple electrical circuit. So you see in the symbol for an LED, the triangle points to the direction in which the current can flow. The two arrows, these two arrows, they indicate that light is emitted by an LED. Okay, so the current is going to flow in the direction of the arrow. By using symbols to represent electrical components, what becomes easier? It becomes easier to draw and understand electrical circuits. So let us see a circuit diagram where we use everything. So here we have two circuit diagrams, as you can see. In the first one, we are using an electric lamp. Okay, electric lamp or incandescent lamp. And in the second one, we are using LED. Now, as we saw, we are using these straight wires to connect. Then we have a switch over here. The switch is in the off position. And then we have a cell over here. In the second circuit, we have used a battery, that is a combination of two cells. And then it is connected to the LED. Here we are not using a switch. We can use a switch though. There is no problem using a switch. So here we have two figures. A circuit diagram with an incandescent lamp and with an LED lamp. All right. Now we have learned all of it. Now let us learn what is a conductor and insulator. Students, you all must be having an idea of what a conductor is and what an insulator is. So do you know why are we using metal wires for connecting these electric circuits? Can we not use some other materials like plastic or rubber? Okay, are electric wires made, and why are these electric wires covered with plastic? So students, every material is categorized in two different categories. Either they conduct electricity or they do not conduct electricity. Materials that conduct electricity are called electrical conductors, whereas materials that do not conduct electricity means it does not allow the flow of electricity, then it is called an insulator. Okay, so suppose we make wires of materials other than metal and use them for making electrical circuit. Do you think electric current will pass through those materials? No. Okay, so if you connect something, a material that does not allow current to flow through it, then current will not flow and hence the bulb will not glow. You cannot use such materials for making an electric circuit. All right, so here we have a setup. See, we have an electric cell, we have a bulb, and we have a loose point. So in this loose point, we are using a conduction tester. So here you can see that they have put a spoon. Spoon is a metal and it allows current to flow through it. So you will see that current flows through it and the bulb glows. But if you connect something like a rubber or a cork, glass, keys, pins, plastic scales, try with different things and you see whether current flows through it or does not flow through it. The materials that allows the flow of current and makes the electric bulb glow is a conductor. The material that does not allow electric current to flow through it and the bulb does not glow is an insulator. So here in table 3.3, you have a list of objects like stick, scale, bangle, paper strip, candle, key, eraser. You can take you know, scale we have already taken, spoon like the one we took in the previous one. Okay, in same way you can take multiple things. You can take a paper strip we have already taken. We can take string or a thread. Okay, then you see which material it is made up of and then you write down your observations whether the lamp glows or not. If the lamp does not glow, that means that object is an insulator. Okay, plastic, no, so it is an insulator. It will not allow electricity to pass through it. Glass, no, so it is an insulator. Paper, absolutely no, insulator. Okay, wax, no, insulator. Metal, yes, so conductor. Rubber, no, insulator. Spoon, it's made up of metal, right? So yes, conductor. Not all spoons are made up of metal. We are taking metal spoon over here. String or thread made up of cotton, so it won't allow. No, it is an insulator. Okay, so in this way you can put something of your choice and write, make a list of conductor and insulator. Okay, now there are materials which allow electric current to flow easily through it. It's called good conductors or conductors of electricity, which I already discussed with you all. Similarly, the materials through which current cannot pass through are called insulators or poor conductors of electricity. All right, so students, silver, copper, gold, these are the best electrical conductors. However, for making electrical wires, we use copper. Why we don't use silver and gold? Because they are very expensive. Compared to copper, has lower cost and abundant supply. So different types of electric wires are used for different uses. Okay, like we saw in the incandescent bulb, we used a thin wire, okay, which was called the filament. This filament was made up of a metal called tungsten. Okay, so it's not made up of copper, it is made up of tungsten. But mostly connecting wires are made up of copper. Why? Due to its comparatively lower cost and abundant supply. All right. So that's all. Now there is a caution and it's very important. Students, conductors and insulators both are important. Electrical wires, switches, connectors, plugs, sockets, they are all made up of conductors. Insulators like rubber, plastic, ceramics, they are used to cover these wires, plugs, switches. Why? To protect people from electric shock, because we are constantly touching them. So we cannot touch the conductors directly. Otherwise, we will get an electric shock. Do you know why we will get an electric shock? Because our body is a conductor of electricity. So if you touch any conductor, you yourself is a conductor. So electricity or current will flow through your body. So if current passes through our body, it may cause severe injury or even death. So always handle electrical appliances with care. Never touch switches or plugs with wet hands or use electrical devices in wet areas. Never. Or handle equipment with damaged insulation. Never. Broken plugs. Never. Always see that the devices are complete, they are not damaged, the plugs are not broken, and you're not touching it with wet hands. All right. So that's all for today. In our next class, we will be doing the solving the NCERT exercise questions. I hope you all understand the chapter well. If you have any problem, you can put it in the comment section and I will answer your queries. Students, please subscribe to my channel and share as much as possible. That will keep me motivated for making more videos. Thank you. Take care and bye-bye.